In this video, I'm going to talk to you about Unit 7, Day 6, Lesson 3B, Solving Quadratic Equations by Reasoning. Our focus question for this lesson is, what strategies help us find solutions to quadratic equations? In this lesson, students are presented in the Explore portion with various different equations and asked to find the solution. Students are not required to solve these algebraically and are able to use a number of strategies such as guess and check. They can graph, they can try to build a table for the left side of the equation or the right side of the equation until they find an equivalent value. Or they can solve algebraically. Many students won't know yet, as we haven't taught it, how to actually find the square root or set something like this equal to 12 and negative 12. But you might see some students exploring that option, and that's a great strategy to feature. So what I'm going to do in this video is talk through a way to facilitate a closing conversation with students to solidify their understanding of the lesson. So I have this lesson on Desmos because it's a great platform for you to be able to see and collect student work, and you will have access to this Desmos lesson in the link below the video. And so I'm going to feature student work from this equation right here, finding the solution to 432 equals 3n squared. And I provided three samples of student work, and I've already taken snapshots of them as I've shown in previous videos. And I've chosen to line them up here in this way. So I'll explain first how I've lined them up. And for each one, I'm just going to ask students, what do you notice? So the first piece of work highlights a common misconception students might have when solving quadratic equations that look like this. I'm choosing in a previous video, we talked about using a concrete representational abstract way of talking through a closing summary conversation. In this video, I'm going to dive a little bit more into having a misconception and having students have a chance to notice and address and talk about it. So for this slide, we're showing the misconception first. This student used guess and check, but they thought that you do 3 times n and then square it. That's the misconception that lives for this. So they were kind of guessing and guessing until they got really close to a value that gave 432. Okay, because it's a decimal, because there's no perfect square number that multiplies by 3 to give us this perfect square. Okay. So then the next piece of work I'm featuring is a student who solved algebraically, which is an advanced strategy. However, and they probably used guess and check here, they only found n equals 12. So we can talk about that as another misconception that might arise when solving these. A common one is students only find one solution. And then here we have a solution who solved it correctly, and they used guess and check, choosing 12 and negative 12, and they noticed that there were 2 different solutions. Okay. So to facilitate the conversation, I would show students this slide. I would ask them, what do you notice? Students would say they might say they noticed the student was trying out different numbers. They found 2 solutions. 20.8 squared does not actually equal 432. It's a number close to 432. They might notice that the student multiplied 3 times 6.93. They guessed a number that would give them a closest possible value to 20.8. And 3 times negative 0.693. Why did they do this first? Well, they were trying to find a number they could square that would give them an answer close to 432. What's the misconception that exists here? What are they thinking? Well, they're thinking that they have to do 3 times n first and then square it. Why is that not the first step? Why would you not do 3 times n first and then square it? You can give them time to talk about it. You can give them a real... Oops, I want to pull up the annotation tool. You can give them a real situation that shows this, right? So if I had 3 times 2 squared, what would I do first? I would do 2 to the second power and then multiply by 3. Why? Order of operations says we do exponents before multiplication. Oh, so we should find a number that squares and then multiplies by 3 to give me 432. Interesting. What's a way we could simplify this so it's easier to find that number that squares? Divide both sides by 3. 3 times n squared equals 432. The opposite of multiplication is division. We can undo that 3. Just like if it was just 432 equals 3n, we could divide both sides by 3. Same is true for this. And then find that number that fits for the n squared. 432 divided by 3 is 144. So now we can find that value. Okay, so we're not first finding out. Well, we're not first multiplying by 3 and then squaring the number. We're squaring the number and then multiplying by 3. We want to be really careful with that and always come back to order of operations. Okay. On the next slide, we're going to see another really common misconception. So when you're introducing to students, you'll be like, okay, let's look at this next slide. What do you notice they did? They divided both sides by 3 first. Interesting. Why did they do that? And notice how now we've addressed that misconception in the previous slide. So now we see the student doing exactly what we just talked about here. They're dividing by 3 first, and they're getting 144 equals n squared. Interesting. They got n equals 12. What do you notice? Well, they could, describe that. They might notice they only got one answer. There should be 2 answers. What would the other answer be? Negative 12. How do you know? Well, we know negative 12 times negative 12 equals 144. A negative times a negative is a positive. Interesting. So there's 2 solutions here. And this connects back to previous lessons where we addressed that there would be 2 solutions to this type of equation. Okay. So addressing that misconception so students remember that there's 2 solutions. And then the last slide is an actual correct strategy using guess and check, finding 12 and negative 12. What strategy did they use? They used guess and check. You might have the student themselves. How did you find 12? Well, I knew that I had to find a number that would square, and I can multiply it by 3 to get 432. And I knew that 3 times 144 is 432, so I had to find a number that squares to give me 144, and I found 12, and I also knew it was negative 12. They might have done something else. That's okay. Or you can have somebody else explain, what do you think they were thinking? What did they do? Is there a way they can improve their work? Okay, and then after students finish this, you can go to the summarize slide, and students can list out and write what strategies they can use to help find solutions to equations. You might choose to feature misconceptions if you have these misconceptions. You might choose to not feature misconceptions if you see that students are not really showing misconceptions and instead feature the different strategies that students are using and ask students to describe what they noticed there. Okay? But either way, the goal of this lesson is for students to begin thinking about how to solve quadratic equations using different strategies and using their own mathematical reasoning. They do not have to solve algebraically, but they should be thinking about what it means to square a number and what it means to unsquare a number, or which we would call square root a number, even if they're not actually showing that in a representational way just yet.